Okay, this will be part two. So let's get into the question. So again, first thing you do is draw the diagram, label all the forces. Fine. Now, what can we do? We can resolve forces. So we can resolve forces vertically. We can resolve forces horizontally, and we can take moments. Well, we can take moments. There's two sensible places to take moments about A and B, but as there's more going on about A, there's more forces going through it. Makes more sense to take moments about A. And let's see if that gives us enough. And that's how you write that. Okay, so what I suggest you do if you're working through this is have a go at those. Pause the video, have a go at those, and then see if you get them right. So resolving forces vertically, what have we got going up? We've got RA, and that must be equal because it's in equilibrium to the forces coming down, which is 18g, let's write it all out, plus 60g. So that means we can simplify that. RA is equal to 78g. Okay, resolve forces horizontally. We get RB is equal to friction. We've already got what that is on the diagram here, right? Friction is equal to mu RA. So we've got RB is equal to mu RA, and we know RA is 78g. So how we need? Okay, so so far we've got two unknowns really. We've got three unknowns: RA, RB, and this mu, which we're looking for. So we've got one equation, we've got two equations. We're going to need a third equation. So yeah, you guessed it. You take moments about A. Okay, so now there's a bit more work to do because we need to find some distances, and I'm going to add these to the diagram. So right, moments about A. So what have we got going in a clockwise direction? Going in a clockwise direction, we're taking clockwise moments. Wise moments about A. We've got, if you imagine that's the pivot there. This is going in a clockwise direction, the 18g. The 60g is going in a clockwise direction, and then the RB is going the other way in an anti-clockwise direction. So the moment of this plus the moment of this is going to equal the moment of that. So yeah, that should be clear. So we want 18g times by. Now here's the pivot. This is the direction of the force. We want to know the perpendicular distance of the pivot from the direction of the force, which is this distance here. Let's get a pen that works. We want this distance here. That distance there. Okay, so how are we going to work that out? Let's draw a little triangle. Let's do some working down here. So we've got, that's 2.5 meters, and that's alpha, and we want to know this distance here. It's adjacent, so it's cos, so it's going to be 2.5 times cos alpha. We know cos alpha is 3 over 5. We got it there. We've got everything we need. 2 over 5 is 5 over 2 as well, isn't it? So that's 5 over 2 times 3 over 5. That will cancel with that, and we get 3 over 2. Okay, great. So that's going to be 18g times 3 over 2. That's for that one. Now, what about the 60g? So plus 60g times by. Now, for 60g, that is the line of the motion of the force, is the pivot here. So we want now this distance here. We want that distance there. I'm going to put 2 lines on that to make it a bit clearer. Okay, so we want that distance there. So it's going to be 60g times now. How can we get that distance there? Let's do a bit of working. So we're looking at this triangle now, where that distance from A to C, we know is 3 meters. So that's 3. That's alpha. Again, it's adjacent, right? So it's going to be 3 cos alpha. So that's 3 times 3 over 5, which is 9 over 5. So okay, so it's the force, 60g, times by the perpendicular distance. So that's 9 over 5. Okay, so that's all the clockwise moments. That's equal to the anti-clockwise, which is going to be RB. Okay, let's go again. RB is this that's RB, isn't it? That's the line of the force, the direction of the force. So it's going to be RB times by. the perpendicular distance. So it's going to be, now we're interested in this distance here, that distance there, which you'll believe is, I hope you can see the symmetry is the same as this distance here. Actually, let's put 3 lines on it. So we've got 1, 2 and 3. So we're going to need to work out that distance, that length there. Well, let's have a look at that triangle. So we've got, that's alpha. That whole distance is the length of the ladder, which is 5. 3 plus 2, so that's 5. And we're after this distance here. So we've got that's 2 and that's 1, isn't it? Okay, so this distance here is going to be 5, it's opposite, so sine alpha. So 5 times sine alpha is 4 over 5. Good thing we had that ready to go earlier. Let's cancel with that, and we just get 4. So times by 4. And that's our third equation. So they're the 3 equations you should set up, and we'll have one more video in which will be solving those equations.